Assalamu alaikum students. Welcome to the 11th lecture of Artificial Intelligence. I hope you are fine and enjoying these video lectures on AI. I am Muhammad Umar Farooq, lecturer Computer Sciences, University of Education, Lahore. And here is my email address umarfarooq@ue.edu.pk. If you have any question, you can send me an email. Inshallah, I will try my best to answer your questions. So we are covering the problem solving by search technique. So in our previous lectures we covered the uninformed search techniques, and in our previous lecture, in our 10th lecture, we covered the greedy best first search, which is the type of informed search technique. So the second type of informed search technique is A star search. But before going into the detail of A star search, I would like to discuss another search technique, which is the best first search, because the A star search is the specialized form of best first search. So just look at this point. The best first search could allow revising the decision, whereas in a greedy algorithm the decisions should be final and not revised. So this is the main difference between the best first search and the greedy best first search. So look at this example which we covered in our previous lecture, that this is the problem of Romani country map. We are moving from A city to B. So इसमें greedy के अंदर क्या था कि अगर if we visit the node S, then the decision should be final, and we will not revisit these two nodes, the T and Z. So हम क्या करेंगे, हम जस्ट आगे की तरफ जाएंगे. ये हमारा ग्रीडी सर्च एल्गोरिदम था. बट इसी तरह से कि हमारे पास अगर इफ़ वी विजिट द नोड F, then the decision will be final in the case of greedy search. So then हम क्या करेंगे, हम ना तो इस नोड को विजिट करेंगे, then we will not revisit these nodes, just we will move forward in greedy best first search. लेकिन the best first search allow us to revising the decisions, कि अगर हमारे पास जो है वो इसको हमने विजिट कर भी लिया है, उसके बावजूद यहाँ पे जब हम पहुँचते हैं, देन वी क्या हम यहाँ पे आके पता चलता है कि हमारे पास जो ह्यूरिस्टिक है ये पहले से ज़्यादा हो गया है, then we will move backward, so revise our decision कि हम इस तरफ मूव कर जाएं. तो ये बेस्ट फर्स्ट सर्च हमारे पास करती है. तो अब इसको हम क्या करते हैं कि इसको एक एग्जांपल के थ्रू सॉल्व करके देख लेते हैं कि so here is the graph which have nodes A, B, C, D, E, F, G and H. The distance between A to D is 7, A to C is 14, and A to B is 11. So we want to move from initial state A to B by using the best first search. So our initial state is A and the goal state is G. So the best first search is the type of informed search. So it will use the heuristic values. So here is the table of heuristic values, that the heuristic value of A is 40, heuristic value of B is 32, and in the same way the heuristic value of H is 10 and the heuristic value of G is 0. So why the heuristic value of G is 0? Because the G is our goal state. And how can we calculate these values? We also discussed that in our previous lecture, that we can calculate these values by using the straight line distance, which is equal to the Euclidean distance x1 minus x2 whole square plus y1 minus y2 whole square under root. So we can draw the line from D to G, straight line, and the value of that straight line will be the heuristic value of D. So we will move from initial state A to G by using the best first search. So that search technique will use this table as a heuristic values. So just look at this slide, that A is our initial state, and we will consider this node as a root node, and we will use the queue for to visit these this graph to solve this problem. So initially queue is empty, and I will put this node A in our queue. So and I will dequeue this node, this value A from our queue, and check whether it is a goal or not. So A is our not a goal state. So I will put the child nodes which are directly connected to the A. I will put these three nodes into our queue. So the distance between A to C is 14. I write the distance between the nodes over here. So क्या है कि हमने एक और इसमें बात की थी कि हमें क्या रिविजिट करने के लिए अलाउ करता है, तो वो किस तरह से अलाउ करता है. सो जस्ट लुक एट दिस स्लाइड अगेन, that the best first search allow us to revising the decision, but how can it uh, allow to revise the decision, because it use the priority queue. So just look at this slide कि हम किस तरह से हम इस priority queue को हम use करेंगे. So just look at this slide. So the heuristic value of B is 32, heuristic value of C is 25, heuristic value of D is 35. So मैंने क्या किया, यहाँ पे एक priority queue ले ली है. The priority queue क्या करेगी, वैसे queue के अंदर था हमारे पास B, C and D. So हमें क्या करना चाहिए था, पहले B को विजिट करना चाहिए था, लेकिन priority queue क्या करेगी, priority queue will set the priority to visit to visit any queue. So C have the highest priority. How C has the highest priority? Because the heuristic value of C is less than the heuristic value of other two nodes. So heuristic value of C is less, so it has the highest priority, and then the priority of B, and in the same way the D have this lowest priority because the heuristic value of D is 35, which is the highest value among all of these two nodes. So we will visit the node C. So just look at this. I will mark the node, mark the color over here to represent that C. I have visited the node C. So C is directly connected to F, E and A. So A just मैंने क्या किया, इसको ब्लू कलर के साथ मार्क कर दिया to represent that I have visited I have already visit this node. So मैंने just इसको मार्क कर दिया. So I have write the distance between these two nodes over here, between the nodes over here. So the nodes F and E, मैंने क्या किया, I just put these two nodes over here in our queue. So यहाँ पे अभी फिर क्या होगा, अगेन हम प्रायोरिटी सेट करेंगे by using the heuristic values. So the heuristic value of F is 17 and the heuristic value of E is 19. So just look at this. We have previously we have BD. So when we put these two nodes in our queue, so we will set the priority that F has the lowest heuristic value, so it will be the highest, will be at highest priority. So हम क्या करेंगे, जो कि हमारे फ्रंट के ऊपर होता है उसको हम पहले विजिट करते हैं. तो फ्रंट के ऊपर किसको लेके आएंगे, जिसकी ह्यूरिस्टिक वैल्यू सबसे कम होगी. देन the heuristic value of E is 19, which is greater than the value of F. So this will be our at our second position, and in the same way B and D. So then I will visit the node F. So just look at this, and I mark the red color over here and to represent that I have visited this node and I have checked that कि हमारे पास ये गोल है या नहीं है. So just हम क्या करेंगे, ये F is directly connected to G node. So just I put the G over here. So then I will again set the priority of all of these nodes. So a G node have the heuristic value of Z, which is the smallest value among all the E and D and B. So then I will visit the node G which is our goal state. So हम यहाँ पे इस तरह से इसको विजिट करेंगे और इस तरह से हम priority queue को यूज करेंगे इस during this search technique. So we solve this problem by using the best first search. We choose the heuristic values as well as the priority queue, and we also discussed that how this search technique use the priority queue to solve any problem. So but we did not discuss the mechanism of revising any decision. So just look at this slide. हम इस slide के ऊपर देख लेते हैं किस तरह से वो how the best first search allow us to revise our decision. So just I change the heuristic values, that the heuristic value of C is 15, heuristic value of D is 35, and the heuristic value of B is 16. So because the heuristic value of C is less than the heuristic value of B and D, so we will visit this node C. Then the child nodes of C will be the F and E. So हम इसको क्या करेंगे, then we will put these two nodes into our queue, F and E. But just look at this mechanism कि अगर इस तरह से हो जाए, if the heuristic value of child nodes, the child nodes which child nodes of that node which we have explored any node, so the heuristic value of these child nodes is highest than the heuristic values of any node which are available at parent level. So then we will visit the nodes which are available at parent level. So क्यों, क्योंकि उसकी प्रायोरिटी जब सेट होगी तो प्रायोरिटी में क्या आ जाएगा, तो वो हमारे पास फ्रंट पे आ जाएगा. जस्ट लुक एट दिस प्रायोरिटी क्यू. So because the heuristic value of B is heuristic value of B is less than the heuristic value of F as well as the heuristic value of E. So B क्या आ जाएगा, B हमारे पास फ्रंट पे आ जाएगा. हम क्या करेंगे, हम B को विजिट कर लेंगे instead of visiting these the any node from these childs, these nodes. So देखें हमारे पास ग्रीडी एल्गोरिदम क्या करता था, ग्रीडी एल्गोरिदम जस्ट जब हम इसको एक्सप्लोर कर लेते थे तो उसको हम क्या करते थे, दोबारा उसके पेरेंट के जो नोड्स होती थी, पेरेंट लेवल के ऊपर जो नोड्स होती थी उसको जो है वो नहीं विजिट करने देता था, लेकिन ये अलाउ करती है क्योंकि ये क्या कर रही है, ये यूज़ कर रही है जस्ट प्रायोरिटी क्यू को. Then we will explore the node B which is directly connected to E. So इसी तरह से हम क्या करेंगे, जस्ट ये एक मैंने एक assumption ली थी, एक एग्जांपल ली थी कि किस तरह से जो है वो हमारे पास बेस्ट फर्स्ट सर्च टेक्निक जो है वो अलाउ करती है हमें अपने डिसीजंस को रिवाइज करने. So look at this slide again. In this video we will cover some basic points about the A star search, so which is the second type of informed search technique. So the basic points for A star search are here. So for A star search, the function f of x is equal to g of x plus h of x. So what is the g of x? G of x is equal to the g of x is the cost from initial state to root state, node state, so node x. तो जहाँ जिसकी हम g of x कैलकुलेट करने जा रहे हैं वहाँ से रूट तक हमारे पास जो टोटल डिस्टेंस होगा that will be equal to g of x. So in our previous two search techniques, greedy best first search as well as in best first search, both of them are using the heuristic value as a function. So the function value of this function will decide the जो कि हमें डिसाइड करती है कि नेक्स्ट किसको हमने एक्सप्लोर करना है. तो the A star search technique is also an optimal search. So it when this search technique is optimal, the search technique is optimal if the heuristic is admissible heuristic. So what is the admissible? कि हमारे पास क्या है कि जो guess है, गैस की वैल्यू जो आई हुई है वो हमारे पास ओवर एस्टिमेटेड ना हो, बल्कि लेस हो एक्चुअल से हमारे पास. So if the heuristic value is admissible, then the A star search technique will return the path which have the lowest cost among all multiple paths to reach from initial state to goal state. So the third property of this search technique is that A star search is a complete search. So what is the meaning of completeness? That it will give the assurity to find the goal if the goal is present in our search space. So the fourth property is that A star search is a well-known form of best first search. So best first search use the best first search allow us to revise our decision, as well as the best first search technique also use the priority queue. So the A star search also allow us to revise our decisions, as well as it will also use the priority queue. So just look at this map again, a simplified road map of part of Romania, that any traveling salesman want to move from arid city to Bucharest. We solved this problem by using the greedy best first search in our previous video lecture. The path cost for that for this problem was 450. So the greedy best first search is not an optimal search. So when we also calculate the path, we also solve this problem by using the A star search, and we will calculate the path cost for this problem in our next video, and we will compare the path cost for both of these search techniques. So in our previous video we use this table, the values of this table as heuristic values. We will also use this table for our A star search. So in our A star search, the function is equal to function f of x is equal to g of x plus h of x. So in this video lecture मैं just आपको ये g of x बताऊंगा कि किस तरह से क्या हम कैलकुलेट करते हैं. इंशाल्लाह we will solve this problem in our next video. So just look at this slide, that the city A to city T, and how can we calculate the value of f of t. So the f of t is equal to g of t plus h of t. So the value of h of t, we can get this value from this table. H of t is 329. But what is the value of g of t? Look at this graph again. So the distance between the A and T is 118. So the distance between initial state to that state is equal to g of x, which is equal to 118. So यहाँ पे देखें कि just look at this point, that g of t is 118 and h of t is equal to 329. We just add up these two values, which is equal to 447. So in the same way, just look at this point, that how can we calculate the value of h of f. So h of f of f, so f of f is equal to g of x, g of f plus h of f. So the h of f, we can get this value from this table. The h of f is equal to 176. So here is the value of h of f, which is equal to 176. So the g of f, what is the value of g of f? So just look at this again. The g of x is the cost from initial state to node x. So if the node is f, so the cost from initial state is our arid a node. So 140 plus 99, so which is equal to 239. So this value will be our g of f. So the value of f of f is equal to g of f plus h of f. So just add up these two values, 239 plus 176, which is equal to 415. So just look at the difference between the greedy search and the A star search. So हम क्या करते हैं कि जस्ट उसका फंक्शन ही डिफरेंस है, फंक्शन ही हमारा डिफरेंट है जो ए स्टार के अंदर हम लगाते हैं या हम इसके अंदर ग्रीडी सर्च के अंदर लगाते हैं. So inshallah, we will solve this problem in our next video. If you have any question, you can send me an email. Inshallah, I will try my best to answer your question. Thank you for watching this video. Allah Hafiz.